Okay, so my video drivers on my computer are out of date, and there's no way to record anything on the computer right now from the screen capture, so I'm going to use my cell phone, and hopefully this will work for making this video. So right now you're seeing the webpage that my students will use during the quadrilateral discussions, and they have a lesson plan where they have to use inquiry to figure out the different properties of parallelograms, squares, rectangles, rhombuses, trapezoids, and kites. And so this website, which is, if you can see up here, Math is Fun, Quadrilaterals Interactive, this website will be able to show how the different properties affect the behavior of the particular quadrilateral that they are looking at. So if you look around this webpage, it's set up a little bit like GeoGebra, but it has a lot of constraints on it, so it's easy for students to see what they're doing. So you might have seen at the beginning I had everything going at the same time, but right now we have it set on any quadrilateral at all. So you can take any of these points and you can move it freely, and you can make it into whatever shape you really want to. There's no constraints on any of the points when you move them. And if you'd like, you can change it. You can toggle these angles. So now you can see what all the angles are. And in any quadrilateral, you'll be able to see that they add up to 180 degrees. Or sorry, 360 degrees. And then you can also put the side lengths on there and see the differences between the side lengths or similarities if you get into some of these other quadrilaterals. You can also put the diagonals on there. Now, this part isn't quite so informative to students because you can't see how long the diagonals are or the angles between them. So I do wish that was a feature that this program would do. So I'm going to leave the diagonals off for right now, but put the rest of these on, and we can go through what the students will be able to see. So you change to a parallelogram, and all of a sudden, you can't move this as much. So if you move the point B, the rest of the shape will move with it, and it'll keep those sides parallel all the time. And then students can play around with this and look and see, oh, the sides on the opposite are always congruent, and our opposite angles are always congruent as well. And there's also a question on the table they'll be filling out about the consecutive angles. And as you can see, the consecutive angles will add to 180, and they are supplementary. So if you change it then to a square, now we have 90-degree angles, and the 90 degrees can't change. So when you move this, it gets bigger and smaller really quickly because all of those sides have to stay the same the whole time. And this figure will only move in ways that a square would move, no matter what point you choose to use. And then we can go over to a rectangle. And in a rectangle, when you move it, you can only move it side to side. So we keep those 90-degree angles and we keep the opposite sides congruent, but not all the sides are congruent. And there's only some ways that you can move some of these, like some only move up and some only move over, which is kind of annoying when you're working with it, but I think that it's good for the students to see the constraints that there are on rectangles. So then if you change to a rhombus, now all you can do is change the angles. The side lengths don't change at all, which will help students so they don't accidentally look for the wrong thing. So they're always going to be these 150 side lengths, and they're all going to be congruent, where the angles are the ones changing, and now our opposite angles are still congruent because it's a parallelogram, and the supplementary, or the adjacent angles are supplementary. Trapezoids get a little strange because when you move them, you can move this point anywhere you'd like, and the shape will follow in order to give you one pair of parallel sides, but the rest of it won't change too much at all. And this probably isn't like a trapezoid that students have seen before, so if they're struggling, I would go to their computer and I would set up a trapezoid that looks more like what they think of as a conventional trapezoid, which if you're watching me right now is harder than it looks because there's something like it. It's kind of sideways, but that's okay. So you can make this the traditional, the regular trapezoid. So then moving on to a kite, this one might be where it is most important to put the diagonals in, because one of the defining features of a kite is that the diagonals are 90-degree angles to each other. And so now you can only move constrained by these diagonals, which is easier to see with the diagonals on. With them off, it still happens, but you might not be able to see them quite so well. So hopefully my students will be able to move these around and see what's going on with them and fill in the table that they have with the different properties of quadrilaterals so that the next day in class they can come up with definitions and also the hierarchy for them.